Hello, good afternoon. Now we are in the topic of the p block elements. In that, the 14 group elements we are going to study. In the 14 group elements, generally prefer the silicon family. Silicon having the maximum physical and the chemical properties. So we are on the study of the properties of the particular group of the group 14 elements. Group 14 elements is understand by the understanding the natures of the carbon atoms. Carbon family is known as the group 14 elements. The group 14 element resembles the properties like the carbons having the same electronic valence electronic configuration same, that is having the 2p electron to ns2 np2 electronic configuration as the outermost shells. Now we are on the points of the trends in the properties. So atomic radius and the ionization energy. Atomic radius of the elements of the group 14 increases to some extent with increase in the atomic numbers. Ionization energy decreases as we go down the group through it. It is not seen regularly. This regular trend because of the interarranging the orbitals shieldings. Next is the metallic and the non-metallic characters. Non-metallic character increases as the atomic numbers decreases. First two elements, carbon and silicon, are distinctly non-metals. Germanium is the semi-metals with some metallic properties, while last two elements, silicon and lead, are the distinctly metals. The increasing tendency to form the metals M2 plus ion and the acidic and basic nature of their oxides and the hydroxides also confirm the increase in the metallic character from carbon to the lead. Oxidation state and inert pair effect. Outermost valence electrons are the ns2 np2 naturally either lose the 4 electron and again the 4 electron acquires the stable configurations. The total ionization energy is very high from removal of the 4 electrons. Very high amount of energy required, hence the plus 4 oxidation state number presents. The element do not form the minus 4 oxidation state. The only alternative left is to share the 4 electrons with the other elements. When they form the compounds in the plus 4 oxidation state, one of the ns2 electron is excited to higher np orbitals and form the 4 half-filled orbitals. The stability of the 4 oxidation state decreases and that of the plus 2 oxidation state increases from carbon to lead. This reluctance of the ns electron pair taking part in the bonding is called as inert pair effect. Silicon forms a stable compound like SiH4, SiCl4 etc. with the plus 4 oxidation state. Germanium and the tin form the compound in the plus 2 and the plus 4 oxidation state. Pb is the plus 2 oxidation state oxidizing agent and the more stable than the plus 4 oxidation state. Due to inert pair effect, Pb2 plus is the more stable than the Pb4 plus. Stability of the lower oxidation state increases and that of the higher oxidation state decreases in the group with increase in the atomic number from carbon to lead. Melting and boiling points. Melting and boiling point of the elements of the group 14 element decreases and we move down the groups. Carbon and silicon show the very high melting point as they have very stable diamond-like lattice and strong covalent bonds. Hence the carbon and silicon, particularly carbon, shows the very high melting points. How silica is found in the natures. Discuss the structure of the silica. Silicon dioxides. SiO2 or silica is the most common compound of the silicon. It is the most abundant compound in the earth crust. It is commonly decreases in the form of the ordinary sand but also exists in the quartz, rake, crystal and the methyl agitated flings, jobs and the opal. Structures. SiO2 silicon dioxide has an infinite dimensional structures, polymeric structures in which each silicon is the link covalently with the 4 oxygen atoms. Silicon atoms. Each silicon atoms has only half share of each of the 4 oxygen atoms, with its ratio of the silicon oxygen atom in the silicon molecule is as the 1:1/2 into 4. is equal to 1 is to 2. The silicon atoms, oxygen, silicon, oxygen, silicons. The dimensional polymeric structure of the silicon dioxides. Large number of silicon dioxide tetroxides, tetrahedral are together. Silicon atomic number 14. Si 14 is equal to 1s2, 2s2, 2p6, 3s2, 3p2. O8 is equal to 1s2, 2s2, 2p4. An electronic configuration in the s orbitals having the 2 electron and p orbitals having the 2 unpaired electrons. In the ground state, in the ground state, the s orbital having the 1 electrons and the p orbital excited state form the bond that is SiO4 for oxygen atoms involved in these reactions. Tetrahedral structure is formed. Give the preparation of the SiCl4. Discuss the structure of SiCl4. Silicon tetrachloride is prepared by the chloride actions of the various silicon compound such as the ferrosilicon, silicon carbides, or the mixture of the silicon dioxide and the carbon. In the laboratory, SiCl4 can be prepared by melting silicon with the chloride Si. Silicon with the chlorine atoms give the SiCl4 structure. It shows that structures. So it shows that the sp3 hybridations and the electronic configuration is equal to 1s2, 2s2, 2p6, 3s2, 3p2. Ground state electronic configuration: s orbital having the paired electrons, p orbital having the 2 unpaired electrons. Excited state gives the 4 unpaired electrons, and the reaction with the chlorine atoms form the 4 bonds sp3 hybridized atoms. For hybrid orbitals of the silicon overlap half filled 3p13 plus of the 4 chlorine atoms. Geometry of the SiCl4 is tetrahedral with the bond angle of 109 degree. 9 minutes. SiCl4 is the formed tetrahedral structure of the SiCl4. Occurrence of the extraction of the germanium. Mineral containing germanium. Germanium does not occur in the nature. It is a rare found in the traces. Occurs in the small quantity in the minerals like the Ag2O. This minerals is mostly found in the Germany. Germanite 7 GeSFES 2 It is found in the South Africa. And Canfieldite 4 Ag2S Age2NS2 is found in the northeast. Extraction of germanium. Ge formate minerals. Extraction of the metals from its mineral or are involved 3 steps, namely the concentrations, refining, and the reductions. The extraction of germanium. Germanium is usually extracted from the RGDS or the germanite ores. Extraction from the rhodite or the germanite ores by the wrinkles methods. The finally powdered dry ores is fused with the Na2CO3 and the sulfur. The fused moss is extracted with the water and treated with the dilute H2SO4. Then filtrate to remove the impurities like As2S3 and Sb2S3. The filtrate containing the soluble germanium salt is treated with the excess of the HCl. Filtrate containing the soluble germanium salt is treated with the excess of HCl and saturated with the H2S to the PPT germanium as a Ge2S. This PPT is the washed roasted with the HNO3 ignited when the G2S is converted to the Ge2O. Reduction of the Ge2O2 to germanium. GO2 is placed in the highly pure graphite doubled and is reduced to germanium by the heating 600 degrees centigrade to 900 degrees centigrade in the presence of H2 gas. GO2 plus 2H2 gives germanium plus 2H2 GeO2 plus 2 carbon gives germanium plus 2 CO extraction from the germanate ores. Powder dried heated at 350 degrees centigrade. In the atoms of the chlorine to obtain the as GeCl2 along with the AsCl2, S2Cl2 which are separated by the fractional distillations. GeCl2 is the GeCl4 is the distilled ore at 83 degrees centigrade. Distilled GeCl4 spared with the vigorous stirring over the crush ice when the GeCl2 get hydrolyzed GO2. The hydrated GO2 is saturated with the chlorine distilled and hydrated with the ice white precipitate obtained on the resigning the and ignitions use the GO2 with and reductions with the S2 and or the carbons use the germanium continuous. Next is the about the give the preparation of the borax. Borax can be obtained boric acid Na2CO3 plus 4S2 S3BO3 plus Na2CO3 Na2B4O7 plus 6S2O. Next is the point regarding the techniques for the purification of germanium selenium silicons. The zone refining method is most commonly used for the purification and extraction of the germanium and silicons. We will discuss these methods in the next lecture. Thank you.